Hello, dear students, Jai Hind, very good morning and welcome back to revision session. As you all know that we have, since you have already been broadcasted 3 lectures. Those 3 lectures which you received already were actually the revision lectures, but not for those theoretical topics, but they were revision lectures for discussing some of the examples. Understand, though as far as some of the topic that updated list of the board has come, understand there may be minor variation in the list of the topic, but our target is, because you are going to appear for NTSC phase 1, where you may come across some of the MCQs based on even examples. So dear student, in first 3 lectures, as you have received PDF from me, in that PDF 1 to 15 examples which we have solved. Some of the example in the last that 12, 13, 14, 15 around, they were actually MCQ based, and some of the examples we have already discussed in detail. Okay. Now, in today's lecture, we are going to discuss some of the examples based on lens, as well as also for the power of lens, how many examples we can cover in today's lecture. Let us see first. Okay. But as I told you, basics, like before we started our discussion regarding spherical mirrors, I mentioned some of the important points for you, and those important points carries much importance when you solve any example. Now, dear student, here in lens, when you deal with the numerical of lens, you have to clear some concepts in your mind. Understand which are those concepts. Before that, let us title this. Okay. Chapter 10, as you know, light, reflection and refraction, and refraction. Okay. And dear student, today you are attending in this lecture number 4 of revision. Okay. One very important thing which I want to first share with you before we start discussing various numericals regarding lens, dear student. One very important thing which we want to discuss today. Now, dear student, before we discuss those important points, uh, before I mention those important points which are necessary for us to solve various numerical based on lens, make some of the points very clear. understand? See, dear student, some of the points, even for lens, one thing which I should mention, one very important point which you need to remember regarding focal length when you solve any example of lens, you have to be very sure about focal length. Just try to remember one very important thing whenever you deal with focal length, and if it is mentioned concave lens, please try to understand. If it is mentioned, understand regarding concave lens, or it has been mentioned convex lens, keep yourself very clear. Concave lens, focal length is always negative. Please remember this, because this might help you in solving the example correctly. Whenever you deal with convex lens, focal length is always positive. This one aspect you need to keep very clear in your mind regarding focal length. As you know, we have also followed this when we have started solving the numericals regarding mirror. Understand here, concave lens focal length has to be negative. Convex lens focal length has to be positive. Now, dear student, one another very important aspect, that is position and nature. Try to understand, dear student. In lens, it is totally contrast. Understand, to the mirror. Try to understand. Before I mention some of the important aspect regarding position and nature, if you can sum up in yourself, that's why I send you the PDF in advance. Just gather all lens diagram understood regarding convex lens, where you are getting all the image mostly. See, I just want to give you a simple glimpse of this. Suppose I just want to give you a glimpse of it. Suppose this is lens. When you keep object, I just mentioning, if you keep object at infinite, image is obtained here at focus. Means image is on the right side, means on the other side of the lens, and image is, as you all know, real, inverted and diminished. Suppose, dear student, here is 2f and here is f. Now if you keep the object here, also you are getting the image here, means on the right side, on the other side of the lens. Suppose here, the image is also obtained here. Suppose object is here, image is obtained here. Okay, so dear student, is it one thing is clear in your mind? This location which I have just shown are actually representing the image distance, which is obviously going to be positive as per the Cartesian rule, because you are moving from pole to, means optical center to the right. So whenever, dear student, V definitely needs to be positive, because you are moving from optical center to the right side. So whenever V is positive, try to understand, dear student, whenever V, that means the image distance. I haven't drawn yet, I haven't discussed one diagram regarding the convex mirror. I just want to make basics clear. I have just discussed the four image. I haven't discussed the image obtained when object is placed between optical center and focus, because you know the image is somewhere here, it is formed. But just now I am refraining myself from our discussion to this. Just now think this only. All images are on the right side of the lens. Understand? Means on the other side. Object is always to be kept on left side and image is obtained on the other side. That means from optical center to the right, it is always positive. Okay? And all these images, dear student, are real and inverted. See the contrast with the mirror. Understood? So whenever in lens V is positive, V, so what can you guess about the image nature? Obviously real and inverted. Make one thing very clear. Real and inverted. The larger, same size, smaller. That depends on the value of magnification. That's a different matter. Understand? But dear student, remember, whenever image distance is positive, image is real, inverted on the other side of the lens. That's the basic fact you need to remember. You see, this is totally contrast to the mirror. And dear student, one image in convex lens you get on this side. If you just draw, suppose concave lens, so in case of concave lens, you are getting one image here at focus and one image here, which understand. So both the images are obtained on the left side. Here also one image you obtain on left side, which are virtual erect, virtual smaller, virtual diminished. So here, dear student, because we are moving on the left side from the optical center, so obviously V is negative. Are you catching my point? Because V is negative, the image is virtual and erect and on the same side of the lens. So this very important point. V negative, that means image are virtual and erect. These are very important points you need to keep in mind, and whenever you solve any numerical regarding the lens, you have to be very sure regarding this. In case of, dear student, concave lens, image is never obtained on the right side. Please have a note of this. So U is the always negative, but V is always negative in case of concave lens. In case of convex lens, it can be positive, it can be negative. Mind this important fact. In case of convex lens, we can be positive or negative, but in case of concave lens, V is always negative. Is it clear in your mind? So, dear student, these are some of the basic concepts you need to remember in your mind whenever you solve any numerical regarding the lens. These are the basics you need to keep in touch with. Concave lens, understand. One more point which I want just discussed, I need to mention for for convex, V may be plus or minus, but for concave, V is always negative. Please mind this, some of the important points which are going to help you a lot. Understand, focal length for concave always negative, for convex always positive. V positive, real inverted. V negative, virtual erect. For convex lens, V can be positive or negative, but for concave, V is always, always and always negative. You understood? This important points needs to be kept in your mind. Okay. So, dear student, keeping this some of the points in our mind, we are going to solve some of the numerical. Continue from your PDF already. Number 16. Okay. Number 16 we are discussing. You first just read from your PDF. Number 15, those last were the MCQ based, which we have already discussed. Understand, in our lecture number 1, some of the MCQs. Now target is regarding lens. You just verify number 16. What is given? I am reading. You have the PDF. A concave lens. Whenever, dear student, you read any sum, this important point needs to struck in your mind. What is given? A concave lens has focal length 15 centimeter. Concave lens, it has to struck in your mind that focal length is to be taken negative. At what distance should the object from the lens be placed so that it forms image at 10 centimeter from the lens? Also find magnification produced by the lens. Note down important points, dear student. This note out the PDF I have made few examples from your textbook and few from other references. What I need to mention, important points for you are this, that you need to be very conceptually very clear when you solve any particular example. Here it's a talk about concave lens. We just want to separate this department, okay? And we'll keep in touch with this whenever we solve any numerical. You should also, dear student, note down this important fact whenever you solve any numerical, okay? Because that is going to help you and and that is also going to be a conclusive analysis for solving your sum. Here concave lens is given, diagram struck in your mind for concave lens. U is always negative, but V is always negative. That means you got one conclusive point that your sum may be correct when if your V is negative. If V turns positive in case of concave lens, your sum is going to be wrong. Okay. What is the focal length has been given? F. 15. Obviously, I would like to take it negative because it is regarding concave lens and it has been given image is also formed at a distance of 10 centimeter. Here, my dear student, these concepts comes to your direct help. Understand, V, should I take V negative or positive? If you are clear about the concept that in case of concave lens, V can never be positive because both the image are obtained on the same side of the lens. Understand? So, dear student, V is minus, okay? U we are looking for, as well you are also looking for magnification. First, the important data we have to note down. Okay, dear student. Now, as you all know, dear student, what I told you that whenever you start any example, you need to mention what here because it is lens, you need to mention as per lens formula. Okay, you must be remembering the lens formula, dear student, as you all know. Okay, let us substitute the formula. What is that? 1 upon V minus 1 upon U equals to 1 upon F. Okay. Let me substitute the given values. 1 upon minus 10 U we are looking for, 1 upon minus 15. Let us transfer minus 1 upon U equal to minus 1 upon 15 plus 1 upon 10. Okay. Now just take LCM. 15 into 10. Just the cross of this. So, minus 1 upon U equal to 5 upon 15 into 10. Just a simple cancellation. Minus 1 upon U equals to 1 upon 30. Just reciprocalize it. 30. Just make a transfer of the sign minus 30 centimeter. So you already got one answer. What is that? That you need to keep the object at a distance of 30 centimeter, obviously in front of the lens, that you all know. Okay. So is it clear in your mind? And one important point we are looking for also magnification. As you know, there will be the change in formula, dear student. V upon U. What is V? Minus 10. What is U? Minus 30. Just cancel it. 1 upon 3 turns out to be 0.33 positive. And you all know this is also the concept clarity regarding concave lens. Concave lens always forms only two types of image: virtual, erect, diminished. Virtual, erect, smaller. So value of the magnification in case of concave lens can never be negative. Okay, these are some of the conclusive aspects which you need to keep in your mind. So the final answer will be object should be kept at what is the distance? 30 centimeter in front of lens. And what is the value of magnification? Magnification equals to plus 0.33. Obviously, if I ask you what can be the nature, my dear student, you can answer quite clearly. Magnification positive. So, what can you guess about the nature and size of the image? Image is virtual, erect, and smaller. Okay, image is virtual, erect, and smaller. Though in this particular example, nowhere it has been asked to you to mention the nature. You are only asked where the object is kept. Nothing else you have been asked. And you are just asked to find the value of magnification. Rather, nowhere you are asked regarding the nature of the image, but from the just simply from the value of magnification you can guess. Because magnification is positive 0.33 less than 1, you can say that the image is virtual, erect, and smaller. Okay, just have a look at the sum before we move to sum number 17. Okay, just have a look at the sum. Then we will target another example, and before I move to another example, these important points you needs to keep in mind. That's compulsory. Understood? Okay. Now, dear student, as from your PDF, you see sum number 17 we are targeting. Okay. Sum number 17. Whenever you come across any example regarding lens, dear student, the moment the word you read concave or you read the word convex, I suggest that all images has to start revolving around your brain. Understand that convex means 5 types of image, 4 on the right side real inverted and 1 on the left side virtual, erect, and larger. This actually the ray diagram needs to remain revolving in your mind when you solve any particular example. Now you just read the example example number 17 from your PDF. See what is written there. A 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. The distance of the object from the lens is 15 centimeter. Find nature, position and size of the image and also find its magnification. Okay. So dear student, before you solve this example, the type of the lens needs to struck in your mind. It is convex lens. Okay. So first, what is given? The height of the object has been mentioned. What is that height of the object? It is mentioned 2 centimeter. So I would like to write h, that is equal to 2 centimeter. It is convex lens, no doubt. Focal length has been mentioned 10 centimeters. So I would like to take f positive. Why? Because it is convex lens. Concept has to be very clear, and the distance of the object from the lens is 15 centimeters. So you obviously minus in any lens. We are looking for V. That's the value of the V is going to decide position and nature of the image. Okay, right? And at the same time we are looking for M, magnification, and we are looking for height of the image also. So we already mentioned the basic fact and we represented the data here directly. Understood? Now as you, what you need to mention in solving any example, I need to mention number 17 only. Okay. What you would like to write? As per lens formula, I have to mention the lens formula here. 1 upon V minus 1 upon U equals to 1 upon F. Here also, dear student, it happened that when you are solving examples of any one particular chapter and one particular type, you may feel a little more confident because your concentration at that time has to remain on that topic and those formulas only. But when you go for full portion exams, it is going to mess up your mind a little bit. So that's why when you practice any example, and even dear student, when you write lens formula, please be very sure. If you like to write it 5 times, 10 times. Here a minor mistake, if you just alter, and if you by mistake write 1 upon U minus 1 upon V equals to 1 upon F, going to totally alter your calculations. Understood? Be very sure regarding this. We are looking for, U has been given, F, that is 10. Okay. Now here 1 upon V minus plus 1 upon 15 equals to 1 upon 10. 1 upon V equals to 1 upon 10 minus 1 upon 15. I told you when example comes in front of you and the type of the lens you read, immediately understand the lens diagrams has to start revolving in your mind. For convex lens, understand, as you all know, dear student, we can be negative or we can also be positive. Understand? Unlike in the case of concave lens. Okay. So here it's a simple question of taking LCM fifth cross. So 1 upon V equals to 15 minus 10, 5 upon 10 into 15, 1 cancellation, 1 upon V equal to 1 upon 30. So V equal to plus 30. Okay. V positive, your concepts, image is real inverted and where it is positioned on the other side of the lens. So you already be sure about a few aspects. Which are those? V positive. That means image is obtained at a distance of 30 centimeter on the either you write right side or you write other side of the lens, and because V positive, image is real and inverted. Okay. So V is found out means you already got position, nature of the image. Understood? Now it's a question of guessing regarding the size of the image, and for that first you find, okay, M V upon U. What is V? 30. What is U? Minus 15. Just cancel. M turns out to be minus 2, and obviously, dear student, V plus M is contrast here. That was not the case in mirror. In mirror, all sign were similar. Here, this needs to be a contrast sign. Understand? In first example, you saw V negative, M positive, V positive, M negative in case of convex lens. M you got. Now the new one, M H dash upon H minus 2 H dash upon 2. So H dash equal to minus 4 centimeters. So now, dear student, what will you write? Finally, in your answer, this is like this. Image is obtained at a distance of 30 centimeter on other side. This word are sufficient, on other side. What can you guess about the type from this? It is real, inverted, and of 4 centimeter. Okay. Just have a look at the sum and just have a look at the highlights. Understand? V positive, M minus, this needs to be contrast in case of lens. Okay, image 30 centimeter on the other side. You can utilize the word right side also. That's it. That is also going to work because V is positive, it is real inverted, and size so you just found out from the value of magnification. Just you have a look at the sum first and note down. May we have covered this example, if I can remember, in our regular explanation lecture, but in revision, we are taking it in such a way that your basic aspect needs to be very, very clear in solving this example. Understand? These basic facts are going to help you a lot understand for concluding at the end of the sum whether your example which you have calculated is correct or not. That's why this concept needs to be kept in your mind. Understand? Some basic facts: concave, focal length negative, convex, focal length always positive, V plus, real inverted, V minus, virtual erect. For convex, V can be positive and negative, but for concave, V is always and always it is going to be negative. Okay. So dear student, as you all know, in today's lecture, we have already started our discussion regarding lens. Okay. Further also in the next lecture we are going to continue discussing few examples regarding lens from your PDF. We have just now discussed two examples. Example number 16 and 17 from your PDF. Okay. Rest of the examples we are going to discuss in our next lecture. Okay. But my guidance is that though the sum of the few points has been delisted and eliminated, understand from your board regular curriculum for the board exam, but this basic concept clarity, understand, you need to keep in mind not for the preparation of NTSC phase 1, but even in 12th standard science when you go for studying optics, which I mentioned when we started both this chapter 10 11 of optics, that optics is a vast concept, and if you are clear about this basic concept of the optics, then it is going to help you a lot in further standard also. Okay. So dear student, as we started discussing the numericals of lens, will continue in our next lecture also. Okay. So just don't solve the sum, but make your basics very clear. Okay. Thank you very much.